Hey, Mr. Beam,
Hi.
Hey, Dick.
thanks.
Hello.
Thanks for your Christmas card.
Oh yeah. Well, at least I had some observatory stuff in there. So.
Yeah, so let's see. What do we see in your observatory here? What are these? This ring over here.
That's the wheel ring is on the underside and the dome ring is on the top side. So they call it the wheel ring because that's where all the little whatever it is inline skate wheels are. Okay. And so that wheel ring, you know, we were talking about, oh, is the pad level, you know, because we were concerned about Bob Richards was concerned about that. That observatory is built in quadrants. Okay, so leveling is very important. My observatory, all I got to get is level is that wheel ring, in my opinion, because that's what's going to be determined what the dome is going to do. So the rest of it is just getting it up to that point is basically those 4-foot structural pieces that actually take it up to 5 feet, I think is where that wheel ring goes. Okay. And then the dome horizon, you know, with the shutters and so forth is about 6 feet. So
it's 6 feet higher. Your dome is 6 feet above 5 feet.
6 feet to the horizon of the dome.
Oh, okay.
It's at the 6 foot height level. Yeah. Mm-hmm. And so the dome is so that's so then the dome goes up another. Well, actually, I think at that point you're probably a foot into the dome. Let's say, is what I would imagine. See, because you got to have a little bit there for the shutter, the bottom shutter of the dome.
So that's an 8-foot diameter dome.
Right. The dome is 8-foot diameter, and so it starts at around 5 feet.
So, Mike, what diameter is your dome?
8 feet, and it's all 8 feet around. And so Dick has the has a 10-foot substructure below the dome. Correct, Dick?
Right. Yeah. It's
okay, which is very important, really.
Yeah. Yeah. That's what I think. I'm hoping. Now, I wish the shutter was big like that home dome that Bob Richards has got, because I think that shutter is, it's in the 30s. It's like maybe 36 inches, maybe as much as 3 feet. And my shutter is slightly less than 2 diameters of the C14 at 27 inches. So it's going to be tight, and I'm a little concerned too, because with the NP127IS sitting up on top with an aiming station, you know,
Yeah.
the difference between those two scopes might make it so you can't shoot certain things.
Yeah.
Yeah. So.
Well, or it might be, I don't know what the software, you may have to tweak the software a little bit, offset it a little bit, in other words, and consider it like a 20-inch scope and have some sort of offset.
Yeah. Yeah, something. You know what I'm thinking, because I'm not going to have any motors. I'm just going to move it by hand at first just to try to play around with it. And so what I'm thinking about doing is mounting a laser pointer on the bottom of the C14 bar. It's going to be a Lus Mundi bar, the 3-inch 9.
Dovetail.
Well, what I
Dovetail. Yeah, and mount that on the bottom of that. See, I always shoot east of the meridian. Okay, so if you take that laser pointer that's on the bottom of that scope and you aim it in such a way that you're just grazing the shutter, see, then you just let it drift. At that point, you just let see how much you can drift, how long you can drift, and of course that's going to depend on the target too.
Okay, what I bought from All Electronics, they've got for $5 each. I don't know, they still have them. Are lasers with crosshairs, and you could strategically I believe that I had talked about that before.
Yeah, I
Or-
might have not have registered it or something. So yeah, that's an interesting idea.
So,
Hmm.
what you, okay, so this is what it did for me. If you take a look at my screen, my little picture,
Yeah.
okay, and let's see,
I could stop share.
Yeah,
okay,
there you go. That'll be better. Yeah.
okay, so you can
Okay,
see
cool.
right there.
Okay.
Let me turn this off and I'll make it a little bit. Okay.
Go to speaker view as well.
Yeah. Okay, hold a second here. Maybe that's a little bit better. You can see the crosshair there. Whoops.
Oh, wow. Yeah, that's a big one.
So
Oh, wow. How cool is that?
yeah. So
So now you
let's-
have to turn that thing on and off, of course, if you're doing astrophotography, because it would probably screw up the shot, I'm thinking, but
well, the thing is that what I was thinking about doing before I got the dome working a little bit better is you basically put blinders on where the where it should be pointing, and then anything, if it's outside, if it's getting too close, it'll start illuminating up the dome so that you can go, oh, okay, I need to move the dome. It'll tell you which way to move it. You move it away from the beam. So I was going to do that and just kind of sit inside and press on the toggle switch. There's a toggle switch on the electronics for the next dome.
Oh, that you got a motor drive. Yeah. Okay. Yeah. Yeah. I'm thinking motorless, just hand do it by hand.
Yeah.
I mean, at least try it out and, go through it and see. I think that if you're low on the horizon, of course, you've got something that's fairly low south horizon type of deal that it's going to be a problematic. But
on really cold nights, that extra 2 feet that you have is going to matter a lot, because then you can kind of bundle up a bit and kind of like hunker down. Where I'm at, I'm just stuck in front of the mount and the equipment bay, because there's no other room, because I'd run into the counterweight or the telescope. With the 11-inch, it's pretty close, actually. C14 is going to be super close in the next dome, just to get around the
and with that mount, with that
a small dome is really made for what I would say a fork mount that has less of a swing radius. Now, in your case, like my case, because you have to put the mount up so high, it's not going to be a good option if you want to look through a Newtonian telescope. It's going to be definitely oriented towards either a refractor or some sort of Cassegrain type of telescope.
That's kind of what my intent was. I do have the 10-inch astrograph, but I could still put that on a portable mount, so that's not a big problem.
You could always put it inside your dome.
Sure.
It's just that you're not going to look through it.
No, unless you're up on a step ladder.
Right. Yeah.
And then even then it probably be
and the only other downside that I see, especially with the C11, is I can't put as large of a dew shield as I really want to deal with extraneous light. You really
that's what I'm kind of wondering too.
Yeah. So it's, you have to be a little careful. Yeah. So, when I put mine up, put everything up, I wound up cutting off the dew shield, and I don't know if I showed you that it was made out of foam, foam board. But then again, what you could also do if you really want a long dew shield, is slide everything back, put another counterweight on the other side to counterweight
I've
that.
seen people do that. They put a counterweight on the scope. Yeah.
In the case of of my telescope, what I did was I put a counterweight on my scope to adjust for the difference in the weight of the different cameras. So if you take a look right over there, you can see that weight sticking up.
Yeah, okay, yeah,
That's a Los Mandy weight system for fork mounted C11 that I had laying around. And I got the idea in a way from remembering back when we went to the college observatory with that telescope. That telescope was also friction drive, and they had lots of adjustment for internal weights to adjust the balance of the telescope, because you know, even a big professional telescope, it needs to be properly balanced.
oh, yeah.
And so you could see on the side in the mount where there were tubes where the weights would slide. So anyways, again, you might be able to move the weight out one way so that you could slide things down.
Mike, you said you had made a dew shield out of foam board. How did you bend it into a circle, to a cone or a cylinder?
I used a heat gun. And I just kind of like went over it a little bit and bent it a little bit, you know,
Okay.
much like a iron worker does to a piece of steel, right?
Yeah.
You bend it a little bit,
Okay.
and little by little, I got it to the point where, you know, I had it in a proper shape and just glued it together. It worked really well, and actually, it's very rigid and very light. It's actually much lighter than the original dew shield I got.
That sounds very ideal.
And what I did was I slid it inside. If you make it just snug enough, and you can put shims in there, you slide it in where the corrector plate is, okay, and it'll stay there. So, and if you screw up with it, you just get go to Walmart and go to the section where they have the foam boards for kids' science projects, get another one, and, you know, have at it again. So, yeah.
Hey, you know, these focal reducers, this is a subject change, but you know, I'm looking at this stuff and I'm thinking that's going to do me no good with a 35mm camera. Am I correct on that? Because basically what you're doing is you're taking that light cone and you're just compressing it so that you can see the whole thing in a APC size camera. That's the way I'm looking at it. Is that the right way?
I believe that what you've described is true, but I own one and have never used one. So that's just my
Actually, I did with my with
6D?
my 6D, and it didn't do too bad.
Really?
Yeah, I'm not sure how much it affected. You know, you can always do a flat field, okay, and in the case of in the case you're reducing exposure time, you're not always looking after bigger objects. A lot of times you're just trying to, well, how can I, you know, get more sensitivity?
But you're not really trying to widen the field of view.
Yeah, you could get some drop off and some small artifacts at the edge. And most of those things do, but
it actually will work then, huh?
I actually had some flat fields that I did.
Wow.
I don't know if I still have them. I might have nuked them. It wasn't too bad.
See, the vignetting and stuff wasn't really.
Well, you're going to get like, yeah, you could see a bit, but it was a lot less than I thought it was going to be.
And then the flats might take it out. So
right. But again, we're talking about f10 scope made into an f6.3 scope. Okay.
Right.
So that isn't too bad. And I used, I had a Meade 2000 series field flattener. So it seemed to work okay.
Mhm. Good. That's good to hear, because I'll probably try and pick one of those guys up.
Now
So-
the thing, now there could be what could be an issue is, like with the light box in your camera, but producing vignetting, but I'm not sure.
Well, what we did narrow down was the artifact that I've got, where on one side you have like a band. It turns out what's causing that is the mirror. And for that, at that scope, there's at f5, okay, which is f5.2, okay, for that scope right there, the light cone is such that part of that light cone is blocked by that mirror in lockup position. And as far as I know, there is zero that you can do about that.
Other than go to a mirrorless camera.
Yeah, go to a mirrorless camera, and I hear they have problems too.
What problems do you hear they have?
Well, I've heard that they've had vignetting issues as well, and I'm not really sure. I could be wrong. I mean, it's just hearsay, and so I don't have any definite answers on that one at all. But I've heard that the guy, Jurgen, is that the guy's name?
Jurgen.
Yeah, that guy said he was the one that clued me into this, and he turned me on to this astrophotography book, which I have since bought this thing. And in there's an article about this where the guy has a diagram in there, and it shows for an f5 scope, it's this light cone issue. He had a flat, and on that flat he showed that band down there. I said, that's it. I mean, I took one look at it, and I go, that's got to be what's going on. And I suspect that I've got a problem, something similar to that on that 10-inch, on my 10-inch astrograph, and I'm kind of wondering if it's the same sort of a deal, but it's kind of more of a spherical pattern. It's not so much rectilinear like that one.
Well, I have a question. Do you get that band with your NP127 or what it is?
That's
Yeah,
the scope I think you saw it on.
Sorry?
I think that's the scope you said you saw it on, right?
Yeah.
Okay.
And then the 10-inch has got something kind of like that too, except it's different. It's on the one side, but it looks more like it's a kind of a spherical orientation. Of course, that scope has a lot of vignetting,
Yeah.
super a lot more than
Well-
got with the NP.
Well, evidently at F10, there's not an issue.
Okay.
I haven't seen that.
That's really good to hear, because that's the direction I'm going in. So I was kind of thinking, well, shoot, if it's a focal length thing, then I'm screwed.
Of course, I don't need that camera for full frame astrophotography. I just need to fix my dome and have some weather so I can use my QHY 410.
That's your other camera, yeah.
Looks like the weather for the next couple of weeks is going to be pretty rainy, cloudy.
It's down here.
Yeah, I don't think there's gonna be much observatory work going on. I'm gonna try
I
to
have a
do it.
question. Have any of you guys seen the comet Leonard?
Not,
Just a little bit.
no, I've seen it on the internet.
Oh, well, that's cheating. No.
Yeah,
Yeah.
right.
Yeah, Jerry found a great picture by somebody.
Oh, wow.
Oh, geez.
Oh, my word, that looks good.
Oh, Rasa, of course.
Yeah. Yeah, it's got two tails and it's got a nice parabolic head,
Right.
shockwave in front. It's beautiful.
Gosh, that's gorgeous.
I don't know if we can see it now. Can we? I guess we can.
It's a
This
6G.
was taken from Victoria, Australia.
My.
Isn't it going towards the south anyway? So they'll get a
Yeah,
better.
yeah, it's popping down to the south.
Yeah. So I think in
Oh, it's C11 Rasa, F5, F2.2.
a Rasa.
T11 with
Yeah.
a Canon 6D.
Yeah, 3 minutes. Field of view. Just a single exposure?
Yeah.
Some
Well,
freaking
it's a
dark
it's
stuff.
a
You can't
F2.
stack, you can't stack comets. They
That's
change
true.
fast.
Well,
Well, you can, but
Deep-
yeah, as a matter of fact, that's what I did with.
Deep Sky Stacker will do it,
Yeah, it will.
but
Yeah,
they
and
Well,
I-
it
change.
will, but the comet changes so much, it blurs the image.
Yeah, you
No,
got your
no.
choice. You got your choice. You can either track the stars or you can track the comet. And then there's another thing that you can do is you can track the comet, and you can also do the stars so that they're fixed as well. So you got some choices there that you can actually do to process a comet.
Yeah.
So, and I think when I chose mine, I chose to track on the comet, and indeed, that's exactly what I did with Neowise.
Yeah.
I put the tracker right on the head of the comet and guided on the comet head, and then I got the star trail.
Yeah.
The MISA will track on the comet. So
Mhm.
So what
That's-
sort of ISO do you think this person was using when on that camera?
Doesn't say, does he?
3 minutes. I would assume that it's not going to be that high. I'm going to say it could very easily be in the 800 or 1,000 or less ISO is
Yeah.
what I would say.
you can see some of the noise in the background to the left. Where
And
the tail
two
is.
is that if he just took a single exposure and he didn't take a dark and do dark subtraction afterwards, then it could be noisier because of that too as well. So now on a Canon, I don't know about just a regular 6D, but on my MK2, it will do a dark right after you do the shoot. if
Yeah,
wanna
you
do
set
dark
it for that.
subtraction.
Yeah, it's a setting.
Yeah, built in.
I have it on my 60D also.
Mhm.
Actually, they do it in the older cameras too. The 40D did it also.
Mhm.
You have to turn it on and off.
Oh.
Hmm.
What was this, Jerry?
This was from Damian Peach again,
Oh,
I think.
yeah,
Wide field.
in
Oh, that's the-
January.
And that's the comment. Oh, wow.
Comet Panstarrs.
Yeah, this is not Leonard.
Beautiful.
And that's a double cluster, right? Yeah.
Yes.
Okay. I thought that looked familiar.
Perseus, yeah.
If you
Gosh,
tilt
that
it sideways and squint, it kind of looks like a praying mantis staring at you.
What, that looks like it's probably about a 10-inch that he did that with. I'm just gonna say, just because of the field of view, about 1,000 millimeters, maybe.
Yeah.
Yeah.
Yeah, it's a good wide field of view. It's wider than my 1-degree fields.
Uh-huh.
Tilt it the other way, 180 degrees.
Hold on, let's see. I see. Okay.
That's neat with the comment.
Another 90 degrees.
Another?
There you go. There. See the two eyes of the praying mantis, and then the comet is the little mandibles, its jaw. Kind of
Oh.
squint at it, gives you that triangular head look that praying mantises have.
You're talking this one right here.
Yeah.
Very pretty.
Very
Mhm.
good stuff.
He must have made this with a monochrome with filters because of
Why
the
is that?
colors. Because of the colors with the bright stars and
Mhm. Well, no, you can take a single frame color and get those vivid colors out of the stars too, just in how you process it.
Mhm.
If you overstretch, then the stars start losing their color saturation.
Yeah.
So you have to keep boosting it after each stretch.
Come on, kid.
What I do is I use something that's called the mask stretch, which is a very subtle stretching.
Mhm.
And then I make a star mask on top of that before I do any other stretching. And that way I can cover up the stars and keep them from saturating like Jerry was talking about. And
Yeah.
then you can do your, nebula enhancement with your Kurz transformation. And then you can switch the mask over and you do your stars later on. Brighten them up as much as you want.
So Jerry, where is Damian Peach located?
I don't recall.
He's not in
Oh.
France. He's not the guy in France.
No, that, I know that guy's name, and it's not Peach. Peach is either here or he's in Australia. He's a regular at the AIC conference coming up in May. And Bernard Rogallo, whatever his name is, he's a regular there too. And I think he's the one that took that picture that we showed of the Orion, of the Barnard Loop
Oh, that was neat.
on Monday morning. Or a week ago, Monday morning, I forget which it was.
So hopefully Omicron will be burned out by May 20th.
I hope so. Boy, it's sure going gangbusters right now. It's up to 73% of the new cases in the US are now the Omicron variant. And in some regions of the Northeast, it's 90% of the new cases. So it's really getting around. It's not as serious as the Delta, but it transmits just rapidly compared to Delta.
Okay, well, I've got a little show and tell here.
Okay.
I just want to say hello to our Jerry number 2. And
Oh, yeah.
just ask what's going on.
Oh, yeah, Jerry.
Hello. Hello.
Yeah, good. Hello. Good evening.
Yeah, I'm here. Yeah, I'm just here to maybe listen and ask a question also. Yeah.
You have a question?
Yeah, I can listen for. Yeah, I think the question is still related to like maybe using guiding in the scope, because I think I tried one more time after I asked you about guiding, and it's still having a little trouble about it. I'm still having a little trouble about using it. Like if I connect the guiding camera directly to my computer will not recognize my camera. So I'm not sure if it's because the camera need to be connected to the scope or something, but.
Do you have ASCOM loaded onto your computer, the drivers?
I think I have the driver of the specific guiding camera. Not sure if that's the one he's talking about.
What's your camera operating software?
I'm not sure. I don't think I have a camera operating software.
Hmm.
Yeah.
Well,
Well, that's what needs to recognize your camera.
what kind of a guide camera do you have? Is that Orion StarShot? Is that what you got?
Yeah, Orion
That's
StarShot.
what I got.
Yeah.
Is it like the one that fits in like an eyepiece?
Yeah, basically
it's got a
it's after a
USB.
guide scope. You put it after a guide scope.
Right. And it's like an eyepiece, and it has a USB port.
Yeah, it has a
and it's
USB
got-
port.
And then it's got your little telephone jack for your mount plug-in.
Yeah, right.
Okay. So you still, I believe you have to have ASCOM drivers on that computer. I mean, you can't just use PhD, let's say PhD 2 or whatever you're using for auto guiding. You have to have the ASCOM drivers now. So what are you using for auto guider software?
I'm using PhD 2. Yeah, that's what.
Okay, so when you hook it up, what kind of prompts do you get down at the bottom? Does it say like mount connected? And like looping and all that stuff? What does it do when you try to connect to the mount? because that's going to be the first thing it's going to want to try to do.
I mean, I never tried connecting it to the mount. I just directly connect the camera to my computer.
Well, when you go in there, there's a couple of icons down below that you've got to select to do the connect. So are you going through that process to do that connection?
I mean, first step, it asks me to like choose a guide camera, and it says about new profile with a choose a guide camera, and I'm supposed to choose a guide camera, so I chose the Orion SSAG camera. So, and then it says it will automatically detect my whatever pixel size and guide scope focal length, but if I connect it, but it's not connected to my camera.
It's not doing it.
But it does have your camera listed in a list of things to connect to, right?
Yeah, it has my camera listed.
Okay, then you have the drivers in there. Otherwise, it wouldn't show your camera.
Yeah, I have the driver. Yeah, that's true.
Yeah.
Okay,
I mean,
I've got PhD up and running here. Okay, I don't know if you can see it.
yeah, I can see it.
Okay, so you can see that I have here the ZWO, but then I can go down here and click on StarShoot or whatever it is. Okay.
Yeah, that's what I did. I
Okay.
clicked on StarShoot.
Okay, but on the mount, you also have to connect up to the mount. Okay.
I
Yeah.
think I have a different user interface than yours. Is mine is like a different way. It doesn't ask me for mount. Like I can show you my PhD guiding, but I think maybe yours is a Mac one and mine is Windows one. I'm not sure if that's true.
Oh, this is a Windows version.
Okay, never mind then.
Okay, well, it should be pretty similar. You need to be able to connect up to your mount. Question, do these the camera you have, does it have the ST4 connector on the back?
Well, what do you mean by ST4 connector?
Well, there's some of the cameras have two ways of guiding it. One is the computer with ASCOM, and the other is with the old relay interface called ST4, which basically it looked like a telephone jack, and you put the wire in, and a lot of the mounts still have that.
I'm not sure, but I don't think I have a ST4 because I think there are only two cables, one connecting to the computer, the other connecting to the mount.
Yeah, to the,
Are they both USB?
No,
No,
the
one's
the one going to the mount is not USB, but the one going to computer is USB.
it's a telephone jack.
Yeah, RJ.
Yeah,
Yeah, it's this kind of
right.
RJ.
Okay, but the thing is that there's got to be somewhere in your software that tells it. First of all, the computer itself determines what direction the mount needs to go into, and so it tells it through generally two types of interface. One is the old ST4, which is the old relay connector of the Santa Barbara group. Right, there you go. And the other one is through the USB connection where it gets the information. Actually, the computer generates the information on how to move the telescope internally and goes through either the USB to your mount, or if you connect up the ST4 connector, it goes back to the camera and then it sends the signals out to your mount. But in either case, you have to have somewhere in the version of PhD guiding that tells you which way to communicate to, whether it's to a hub or directly to the mount or to the ST4, I believe. So
I guess my confused is that maybe do I need to actually connect both them?
So and any of you guys dealt with the a Macintosh version of it?
No. Nope.
That's what he's got, a Mac. You got a Mac. Wow. How do you do a Mac with ascom?
I don't know.
Oh, you don't. There's something else. It's probably another program that's similar to ascom.
Well, the only thing I could think of is that if you could put the camera in a mode in which it didn't require an ascom interface per se for the computer, but I don't know if that's possible or not. It might be.
I think I just have a Windows one.
Oh, there's a
Yeah.
thing called on camera. I'm looking at the mount. It's on camera.
Yeah, that's it. That's what you want. You want
And that
on
would-
camera.
And
Then
that
that
would-
way, if he's running on a Mac, see, he doesn't have to have the ascom drivers.
now he goes directly with the telephone connector to his mount.
Right, yeah, the
Maybe.
camera supplies the guide signals through the camera. I don't know how it does it, but anyway.
Well,
Yeah, I think the major problem is just first letting my computer to recognize my camera. I can share my screen if you want to see it, but it's like is first it asks me to connect it to the camera. It's like nothing about the mount. Just trying to doing the first step. Yeah. Can I share my screen?
He's faded away. I can't hear him.
yeah.
Yeah, we can't see your screen either, so we can't see what it's saying. You'll have to tell us.
Let me try to share my screen.
Oh, there we go.
Oh
Yeah.
yeah, this one.
Okay,
So,
yeah.
let me reopen the PhD.
Well, that's colorful.
It's the PhD tool. Yeah. So this one, next, I click on next. Is asking me for get camera. So I chose this one. I mean the camera is not here. in
Oh,
my-
hold
my
second.
place.
Wait a minute.
But-
yeah.
Wait a minute. Go back to that. It says ascom.
Where? Here. Yeah, ascom.
Okay, go back to your okay, hold a second here. Could you click out of this here for a second?
Back.
Just back. Go through this. Okay, first.
Oh, first light wizard. Okay. Huh, I've never seen this stuff before. I'm
Yeah,
about
it's a different. It looks
I'm about
different.
2 or 3 versions behind.
Oh, well, I've got the one that does multiple stars that actually
Huh?
guides, but much better. Okay,
Okay. Wow.
go to next here. Okay, click on guide camera and let's see what the different things
Selection.
are. Okay, so
StarShot.
yeah, but
Hey,
let's
down.
see if there's something that's
Yeah.
not
You
a
got Orion StarShot is right next to that
Yeah,
one.
I'm not sure if I should use this one or StarShot AutoGuider.
StarShot Auto Guider.
That's what I would use.
Yeah, because
Okay.
you are not
Yeah.
ASCOM, because you
No,
are
no.
Macintosh.
No, you don't want to go. You want to do. Is this a Mac interface?
No, this is
It's
a
Windows. It looks Windows to me.
Windows.
So you're okay. You don't have to worry about. You can be.
Oh, okay. I thought you were.
And I thought I
Macintosh.
saw
Yeah.
ASCOM drivers too on your desktop.
Yeah,
Yeah, here they
I
are.
I have ASCOM. Yeah.
Yeah, you got ASCOM.
Oh,
So
then
you can go
you should do
ASCOM.
ASCOM. That would
So
be
he can
better.
do whatever he wants, but yeah.
But I think my problem is that if I just directly connect my camera to my PC and my PC still cannot recognize my camera. So
It said it was already connected.
no, I didn't even connect my camera right now. It's
Huh.
my camera is outside somewhere else.
Okay,
Yeah.
so it's not even hooked up yet. Okay.
Yeah.
Okay, can I suggest something?
Yeah. Sure.
Reinstall your driver, but make sure that your camera is connected up to the port you want to use, the USB port. because sometimes, when you install a USB device, it won't recognize it on a different USB port. I don't know if there's an issue like that with your computer.
It's on different USB. So maybe it does not recognize my USB device. Yeah.
Yeah.
Well, you know, there is, he's got a good point there too. I've had that problem, is that
Mhm.
wherever you put the camera, whatever USB port you use, make sure you always use the same port, because that's where the drivers are installed. You go to another port and the drivers might not be there. Now, it's supposed to automatically load them if they're not there, but sometimes it doesn't do it right. So,
Yeah.
you know, that's
And-
one thing.
Yeah. And-
What do you mean by like the same port as the driver?
You want,
installed?
when you hook the camera up for the very first time, and
Yeah.
it does all of the downloading of all of the driver stuff, okay? Make sure that you always use that same USB port, because
The
the
physical
driver
port.
downloads are specific to the ports that you have
Oh,
on
okay.
your computer.
If you don't do that, then the machine goes back to the old port and you have to reassign the port to tell the computer where you're hooked in this time.
Oh, okay,
And,
okay.
and,
But
and,
I
and when you
think-
do it, when you do it, just go through the motions like it's already on the telescope. You don't even have to have it on the telescope. Just have it on the desk there in your house, connect it up and see, and you can just test to see if it works, because you'll be, you know, put a short exposure on, you'll be able to see whether the screen will give you some sort of image, a non-image. It'll be, you know, all white or all dark or all gray. Just put your hand over the front of the camera and you should be able to see the light varying on there. And if you do, then you know that, hey, my camera's working. Yeah.
Oh, I think
But the thing is, click on that USB thing again, at the very left on your, yeah, there, click on that.
okay. I haven't connected to this.
Okay, so it just says that it
It's the
hasn't
first
been.
time.
Yeah, I do not have my camera on my hand right now. so-
Right.
Yeah, but the thing is that, for me, I've had everything connected up and I'm not in my observatory and I'm just trying to, okay, there we go.
That's what I
Okay.
have.
Yeah. That's once you get your camera known, okay, you'll have, go down to where it says StarShot Auto Guider or ASCOM.
Yeah, I guess this one StarShot altogether. I do
Okay.
not have ascom. This one only StarShot altogether. I think.
Yeah, StarShot Auto
No, there's this ascom, whatever. Just
Okay.
choose one of them. Yeah.
Well, you do have ASCOM installed on your computer, correct?
Yeah. Yeah. Right.
Yeah, he's
Okay.
got it. We saw it up there.
Okay, so okay, so the mount would be whatever your mount is. Oh, that's interesting.
Yeah, you
I
can
think-
do on
I
camera.
think I should do on camera. Just as you
If you do
suggested.
on camera, I think that it doesn't use ASCOM, but
Yeah, that's true.
yeah.
So I should use this one then, on camera.
You could try that. That might be
Yeah.
a way to go.
Right, and if you want to, the best way actually is with the ASCOM, because that does pulse guiding. What type of mount do you have?
I have Orion mount.
Okay, yeah.
Well, you got a Sirius, yeah.
Serious,
That's
yeah,
right,
serious.
yeah. You know, I had
So-
to go out there and grab my computer. I got my other laptop and check and see what I've got on mine, because I've got the same auto guider. So at least I can get up this dialogue, that connection dialogue. I'm gonna go do that. I'm gonna go grab it. And that way we can
Okay,
compare
okay.
notes.
I can stop my sharing right now.
Okay. Yeah, most of the time when I get my equipment connected up in my house till I get it working, and then I go out to the observatory.
I'm not sure what do you mean, but like actually, this you said I need to use same USB port. I understand, but I think I never really installed a driver with a USB port or something. I just installed the driver from online and then I just installed it.
Do you still have the driver itself? I would reinstall it again.
This is the driver installation. I can run it right now. It's like
Okay.
this. Yeah, it's just already installed, so it's really quick.
But you should have the camera connected up when you install it, so that it should say camera is working normally. Usually it says.
Okay, sure. I mean, I never connected to camera when I installed this driver. It's yeah. Maybe I should do that next time.
Right.
Usually there's specific directions from your camera about whether you need to have the camera plugged in or not when you install the driver.
Yeah.
Some go one way and some go the other.
Yeah, you're right about that. But
I can go Google about that.
I hope you're not waiting for me. I had to go back out to the shop to get the computer. And I'm concerned that they're gonna have a Windows update. It's been terrible lately, by the way, guys. 2 hour, like almost an hour and a half updates. 2 times in a row. That's why I want to get rid of Windows.
That's pretty slow
What
with
are you gonna
the
get?
solid
You're gonna
state
use
hard
this-
drive.
You know what they're doing is they're loading 11 on. So I got Windows 10 and they're loading 11 on. And it's just so slow. It's unbelievable.
Oh yeah.
Okay, here we are. That was pretty quick, actually. Come on. Okay. Oh, now I got to remember what the
well, if Hank was here, he would say, just put it on a Raspberry Pi.
Yeah. Well, you know, I wished he was here because I kind of wanted to talk to him about some of that stuff too, because, you know, what I don't understand is why doesn't somebody put together a system that's a Windows server that has ASCOM and Alpaca ASCOM on it, and then have some kind of way of mapping the two, see? And then as far as the externally, the user thinks they're probably just basically with ASCOM Alpaca. See, that's kind of what I'm thinking of. Oh boy, now what are we doing?
Let's see, is Alpaca on the Linux?
You can do anything because it's TCP/IP. So you can be Raspberry Pi, you can be Linux, you could be Mac OS. You could be Windows. But see, the common problem here is ASCOM. ASCOM can only be Windows. So if you put it on a server and you had both sets of drivers, you could go across platform that way. See, that's what I'm thinking, and then map it. So why isn't somebody, this is what I don't understand, is when they wrote the spec for Alpaca, why didn't they give some bridge, some way to get there, see? And they didn't do that. And I think that that's the downside of it right there. Somebody needs to write that server software so that you can do that, that you can map it. So I got it up here. I'm trying to get this doggone thing. Here we go. Okay, here's what I've got. I have CMos SSAG Pro camera, ascom. Mount is on camera. And I believe that it's still, you see, it's still needing ascom. But what they're saying is that the actual, that 4-pin interface is on the camera and not on
Yes.
the computer.
Right.
That's the distinguishing feature there. So it's still ascom. So did you get that, Jerry? On my system,
Yeah,
I've got the same thing. I got the StarShot camera, and I put CMos SSAG Pro camera, and in parentheses ascom, and then that's for the camera, and then for the mount on camera.
Let me see. So CMOS, I do not have that.
You don't have it, yeah.
I do not have it. Yeah.
Oh boy, that's the problem because I'm kind of like behind here. Let me see here. Yeah. Shucks.
I only have this Orion SSAG camera, parentheses ascom.
That's what I would select then.
Yeah.
I'd select that one, and then I would also select for your mount as on camera.
Well, what did you choose for AUX mount?
Sorry?
What did you choose for AUX mount?
My mount is on camera. And the mount that I'm using is a Atlas Pro.
I'm
AZH
asking
EQ.
it's the AUX mount. The mount, the one after mount is.
I'm not
Oh, the auxiliary might be like focusers or something like that.
I put it on the text box.
Hmm.
I put it on the chat.
Oh.
AUX.
Well, oh, I see it. Yeah.
I think I should just put on now because I do not understand what they are talking about.
Aux mount.
Yeah.
Uh-huh. Yeah. Like I said, I'm a couple versions behind. I'm afraid to change it because I had to dummy the thing down so much with freaking, they got these aggression constants in there, and they got declination aggression at 100%. I'm going like, what? You should hardly be moving, Deck.
Talk about being a couple editions behind. I'm running Windows 7 Pro.
Oh, wow. Well, my advice would be there for you, Jerry, would be stay where you're at.
Yeah, it works with all my cameras. It works with
What's
all my
that?
cameras. And a couple of my cameras are inconsistent with Windows 10, so I'm not moving.
Uh-huh. There you go. That's a good way to go. They're trying to get me to go to 11, and 7 is so invasive, I can't hardly stand it.
Hmm.
It is the worst operating system I've ever experienced from these guys.
Well, I thought 9 was it. No, what, 8? Somewhere, the one after 7.
8's terrible.
Yeah, that was terrible. We had to.
I know which one you're thinking of is Vista.
Vista was there too, but Vista was renamed as 8 after they made some changes to it.
Oh, did they? Oh my God.
It was still
Yeah,
terrible.
I had Vista and it was terrible.
So the PhD guiding that I use is 2.6.10. And with that one, you'll get multiple star guiding, which means you're not relying on one star, which may wink out or not. It's more robust.
Hello.
Yeah, Jerry.
Well, yeah. Did anybody see the meteor shower?
No.
Meteor shower?
Yeah.
I didn't see anything. I haven't seen anything.
No, the weather's been cloudy here.
It's been pretty crappy.
Yeah. I tried to go once, but then it's like a full moon. I can't see anything.
Yeah.
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 Yeah, that's why we live by us deep sky photographers. We live by the lunar cycle.
Yeah.
So,
I think I'm going to get skunked this whole lunar cycle, as a matter of fact, because I don't think, from what I'm seeing, that the weather's not going to get there. So,
which is the reason why I've tried to go to work on my mirror stuff. So here, let me share something with you. Okay, this is, whoops. Okay, so this is my telescope mirror. I just happened to pick this one. So
Looks like a lot better than your last image of it.
well, this is my 10-inch.
Oh,
put the tried and true one in there first.
Yeah. Okay, so let me just get things. Okay, so this is one wave, and I still think that I'm not really this is as you're going around on the thing there, so I still have some issues. This is with the new laser, but you can see where there's surface area. We thought this was a pretty good mirror, and it looks like I still have some issues with getting the software to work properly, but it kind of makes me wonder about the 14.5-inch that, it probably wasn't ready for prime time. But then again, this, I'm learning more and more about this program. So, I can go here. And another thing too is exposure is really important. So if I go like this here, whoops. No, this here. Okay, so I've got this thing here. Okay, and this is the green light, blue light, and red light is all different. So let's go for the blue here. See. Okay, so you going back to the original one. No, you can't go back here. iGram. Okay, this is very important. This is not proper here. So what we need to do here is go to the edge, zoom, and get this centered properly. And down a little bit more. And probably go in just a skosh. Done. Okay, so what it does is does a Fourier analysis. It tells you you want to get it this as big as possible. You compute your surface. Okay. So it says here RMS is 0.75, and you go around here, you can see where it's going up and down. So I think I've got some tweaking to do on the okay, so with the big blips there, it just means that I'm not covering it properly.
what's the thickness of this mirror?
This is a full thickness.
So it's, what, about 1 3/4 inches?
So I think it's 2 inches.
2 inches, okay.
Yeah.
That would
So
be
you
right
can
for
see,
a 12-inch mirror.
yeah, this is my 10-inch mirror.
Yeah, okay.
Okay, so you can see that, you know, from 1 wavelength. So this is because the edge wasn't properly covered. They usually say that. So if I go like, okay, let's see what that changes. So there's some artifacts here that, you know, I'm trying to deal with, and also you need multiple multiple of these here in order to get the proper need to average them out, because of the fact that as you're taking the images, it's the air is moving things around. Okay, so here's another one. That black dot there,
Mhm.
that's holds up my mirror. That's my mirror stock.
Oh, clip. Yeah.
So I probably need to make that smaller. Okay, done. Again, pull this out a little bit. This is an incredible program, and it's free. Okay, I got something wrong there.
What is that
Okay.
picture with the kind of the rainbow colors up there in the corner? Is that like a
That's
3D?
a 3D. That's my 3D picture. It's, you know,
That's a really rough mirror.
well,
I don't believe that.
no, I don't believe it either. That's what I'm saying, that there's some funkiness that I need to figure out. Let's see here. Maybe move this in a little bit and recompute the thing again. But going back to this other one here, okay. So if we do the results, which is this, we go to the star test. Okay. So that kind of tells me that right here with this, at least with this version, okay, the point spread functions down here, your modulation transfer functions here. We really want to be along this line here. This here is like if we were focused, this is inside focus, outside. So that's telling me that I'm not corrected properly. But,
So this is a 10-inch mirror that you worked on yourself?
yeah, that we thought was had really good results. But again, it's me learning how to use this and doing proper exposures really really matters a lot in here.
So when you shoot the mirror with the interferometer, is it just a one-shot deal and it gives you all this information?
Yeah, it's one picture.
Yeah, one picture, but this is what these are all the pictures I took in the last sequence of here. Now, some of them, like these here, are really overexposed.
Yeah.
Okay, but I got this here going. Okay, let's see what this one looks like done. Okay, so compute. Wavefront RMS 0.14. Strill is, but it says Strill is only 0.44, which would say a terrible. And
Yeah.
What is the Strel number? What does that mean?
Basically, it's a Strill of 1 would be 100% of a perfect mirror, putting everything in the central portion of the Aries circle, I believe. Is that
Yeah.
right? So this is going up and down. Here is, whoops, I didn't want to do that. Wrong clicking. Okay, so on this one here, you can see this is one wavelength. This is 0, so it's pretty much there. And if I go and do the 3D controls, try and stretch it a bit. Yeah, okay. Okay, at least on this one here, it says that the peaks are about 0.3 of a wave, and most of it is not so bad. But
How are you reading where it says 0.3 of a wave? What are you reading?
well, right here on the edge here, the vertical is wave at 550 nanometers. Okay, so you're looking
okay.
down on there. And so this is supposedly low. These are high.
I can't see where you're pointing, I guess.
Okay, you see my mouse?
No,
I see the
No.
pointer.
Okay, the light blue is the high. Okay, if we
Oh.
tilt this down.
Oh, I
Okay,
see, Mark, yeah.
dark blue is low, and the light blue
Okay.
is, yeah.
Is
So
it
if we-
moving for you guys? I don't see the mouse moving around
no, I
at all
don't
or
see the
anything.
mouse either.
oh,
No,
okay,
but you
sorry.
could look at what he's talking about is that.
Yeah, I get what he's talking about.
Yeah, the
Can't see
color
the mouse.
graph is what he's.
Yeah, so
referring
if
to the colors.
we jump out of here and we go to star test point spread function. Okay, so the middle is your area circle. Okay. And at least this picture shows it to be, you're seeing the diffraction inside focus and outside focus. So this could mean that this is saying I've got a turned edge for all I know. So if I were to go here to the ignore edge region and just put like 5 and see what it does. Okay, hold a second.
It did improve your MTF a little bit.
Yeah. Yeah, and look over here, the point spread function, look. Okay, so if we take that away, we go back to 0. Let's see what it does on the point spread function. Because this is basically your airy disk, right? A little bit different.
Yeah, you've lost a little resolution in it.
Yeah. Okay, now if we go to the Ronchi, okay, this is kind of shows like a tester would. Okay. So the left would be the Ronchi and the other one would be the Foucault tester.
Very cool. So what are those
Walking
defects
looks
that we
good. I
see?
don't see any knife edge pattern on the Foucault.
So
There.
that would mean that I got a bad edge.
No, I don't see a bad edge there. See around the dark side of the
Yeah.
Foucault, there's a bright rim.
Yeah.
So Mike, what are those 3 or 4 dots on the mirror? What are those?
Oh, I've got scratches on the mirror for some reason. I don't know how I got them. I've got blemishes on the mirror now. So,
Can you physically see them yourself?
oh yeah.
Not much you can do about that.
No, not really.
Can you put
Yeah.
black dots? Can you black those out so they don't get used?
Yeah, kind of, sort of. I to tell you the truth, I don't know. I moved here. The mirror was perfect, and then it was in the mirror cell with a piece of cardboard over it, and hadn't looked at it for a while, and then all of a sudden I saw those and go, oh shoot. And I thought it was dirt, but it wasn't. It was, I'm not sure if they're scratches or not, or just
Maybe the
defects.
coating is screwed up.
Maybe. One could always hope, but I don't think so.
Yeah, that'd be a real, you could get a real luminance, so.
Okay, so you can see right here, you know, on the left, some of the test images that we kind of take a look at when we go in and out of the focus.
So can you
So-
do this test with a non-mirrorized mirror, just to,
You're supposed to.
Yeah,
okay, yeah.
See, I'm trying to get this to the point where I can start thinking about working on Tom's 10-inch f3 mirror, or is it 3.3? So with the one of the things that I noticed that there was a sensitivity. Hold a second here. Compute. Go back to here. Okay, some of this here on the profile error, that could be caused by not having the appropriate amount of, see, what I just did here to make it look better was it said desire focal length adjustment down on the bottom right. I have it enabled. I just moved that a little bit, okay? And so it put more of the wave in there. So this really is dependent upon accurate focal length determination. So I find that kind of difficult to get with the big 14-inch mirror because it's so fast that I just wonder if I don't have the proper focal length dialed in, and it's probably not an f3.95. It could be an f4 or f3.6 or whatever, which could be causing part of my problem. But at least you can see right over here as I go through the different portions here, you know, for the most part, it's saying that I'm within 1/8 of a wavelength for the most part, except for the very edge, and there's like a bump.
You know, when we do focal measurements, which I know we don't do very much at the museum, but in that you plot the different points where the knife edge is compared to an ideal curve, but you can move that plot up and down without any change because the mirror is only a mirror with respect to itself.
Right.
And so that's exactly equivalent to what you're talking about changing the focal length that it's supposed to be. Because that's what we do when we move that curve up and down. So you can change the focal length until you get the best looking curve. That's completely legitimate.
Yeah, you can see I'm moving it towards, you know, to where it's going the other way.
Yeah.
And so, but this is telling me my Strel is really crap, you know?
0.04, well, there's 0.3.
Yeah. I want 0.9.
Yeah, 0.9 is a very desirable thing.
I want 0.95, you know, but anyways.
This is like a credit rating. You're going to have to work to get it up.
Yeah. So the first thing is I need to know that I'm getting proper results with the test setup. I still think that there's a little bit of variable on a little bit of pilot error, you might say, as we used to debrief the pilots in the Air Force. You know, misadjustment of the interferometer or, so, but one of the things that they did say is don't expect to get any more than, let's say, a half wavelength or wavelength of accuracy on any given exposure because of the air currents and stuff. You need to average them out a lot. So this mirror might look a lot better than it looks now. So they recommend like 10 to 50. I guess some guys goes.
Okay, well, that's interesting.
Yeah. So what I'm going to do is I'm going to start learning how to do that. But anyways, it tells you that this mirror is much closer to a desirable paraboloid than my other mirror.
It would appear that way, yes.
Yeah, much so. But again, I just, it would be nice to know exactly a standardized mirror is so that I could test it and make sure that I'm able to get the data that I should be getting. Another thing too is this is an f6 mirror. The other mirror is an f 3.9, the 3.95, and that's a lot more difficult.
Yeah, much tighter tolerances.
Well, not only that, it's harder to measure. They even discussed it on the thing where it's just more difficult. Anyways, so that's what I've been doing. I just the new laser works pretty well. I think there's some tweaking that I need to do, and getting proper exposures is really important too, I've noticed. And it's not apparent on the camera. On the camera, looking on the viewfinder, I use live view, okay. And with the 5D, you can change the aperture and the ISO speed and the speed and see it right on the screen as it changes, and it's trying to tell you what it thinks it's seeing. But it's obvious that it's not accurately telling me the optimum exposure, and I'm just going to have to experiment with that.
Take a whole bunch of different exposures and then compare your mirror's performance with these different exposures. I'll bet you don't see it change.
Yeah. Another thing too is you need to part of the whoop-de-doos also is covered by stratification of the air in the garage, because in the tutorials they either do it in a tunnel or they say put a fan underneath it and just mix the air up. And he says it's going to look really bad, but when you average them out, you'll get better results. So this interferometer, it has a carrot and a stick, or it has its good things and bad things. The good things is theoretically it should give me indications to maybe 100th of a wavelength of light or something like that, or more likely a 50th or a 25th that I'd be able to measure accurately. The other thing is that you need to take a whole bunch of pictures, and you need to rotate the mirror physically so that you can take out the astigmatism. And
yeah, your system, what you're showing, is something with a lot of non-rotational consistency. It's got rotational error in it. It's astigmatic
you
in a
mean this here?
complicated way, which I don't believe. But you should rotate the mirror and see if that stuff stays, if it rotates with it. I'll bet you it disappears. correlate with the mirror's position.
Yeah. So one thing it could be also it's seeing that notch, and also another thing too, it's also seeing where the mirror's been held up during illuminization,
Yeah,
and that could be disconcerting to the software. So I'll just we'll have to see.
I'm looking forward to your progress as you figure it out.
Yeah. Now, which laser did you get? Type of laser did you get?
I'm
with your
still
kit?
working on the mechanical thing. I put the photometer on hold because I'm finishing off the mirror
Yeah.
clip for my mirror on
Right.
the mirror cell.
Okay. Now
I'll get back. I'll probably be done with it in about a month.
okay. He sell two types of
Yeah, I got the
lasers.
cheaper one.
Okay. Just remember, be careful. Don't overpower it. You can focus those. Another thing too is with the laser, with the more expensive one, it has a larger lens in front of the laser.
Mhm.
And the light beam as it was coming out was going beyond the lens in the lens holder. And I was getting, you can see a spot on there as you move the lens around in front of the laser. Okay, you could see a spurious spot. And so what I wound up doing was putting a mask over the lens so that no matter where I was moving the lens in respect.
Because you're adding diffraction from the edge of your lens into that.
No, well, it's larger than the lens. It's just that it covers where there's areas where.
Right. I mean, if you don't cover it,
What?
that's the problem. If you don't cover it, that's the problem.
Yeah. Yeah. And the test beam, the edges of the test beam are a little vignetting in weird places, but I don't think that's hurting it because as long as it covers the mirror. Now, the lens I have really spreads it over. If my head is the 14-inch mirror, you got you got this large swath of laser light that goes about like this here to my mirror. So it's the pointing of the centering of the test beam is not too critical.
Okay.
But the adjustment of this interferometer is a little tricky because it's got this thing where you're adjusting it in and out, and then it moves up and down in this way for fine adjustment with a screw. And so it's a little tricky getting it properly centered. And then what you have to wind up doing is you have to move the lens out of the way to get things adjusted properly. Then you have to move the lens back, and hopefully it doesn't move it in relationship, that you're got things centered properly. So other than that, I think I have a slight issue with dirt in the optics. Still trying to get that out. It's looking a lot better than it did before. Yeah, there it is. Yeah, the thing that sticks up there is the lens. Yeah, right there. It's you can't see the lens, but it's sort of like it slides in there, and that you flip it up and down to get it in and out. Oh, there, go. Okay, if you go down there, there's all the lenses right there. $10, $15 or whatever the
Oh, you're
for
talking
the
about down
different
here?
focal length.
Oh, he's
Different
talking
focal,
about the list of parts you have there on the right,
yeah,
down,
right
There.
there. Yeah.
the list. that
Yeah.
list.
Okay, so that's what it looks like. If you zoom in on that, you can see how the lens is in that little notch. That's the, yeah, just click on that. Click on that hot link.
It doesn't look like it's a link.
Okay, can you zoom in and out with your,
Yeah, I could do something like that.
yeah,
Oops.
yeah. Oh, whoops.
Hang on.
Okay.
We'll find it.
Yeah, there you go. Okay. So that's an arm, and that little notch in the arm is where the lens is.
Huh.
Okay, so you can see how when you adjust it, it hinges on that screw. And so as you turn it, it could move a little bit one way or another and be slightly imperfect. Yeah. So what I did was, I went through the whole thing. I put the new laser in. I also tried cleaning off the optics. Oh, the one thing I didn't clean was the optics on the laser. So I cleaned it. I cleaned the
Prisms,
it's a beam splitter.
beam splitter. Mhm.
Yeah. And the one thing I didn't clean also was the front surface mirror, because I was kind of like, it's front surface. I don't want to ruin it. Yeah, that's right there. Now, the one thing I did find it's a little there's a couple weak links in it, and one of them is being able to adjust that mirror there the way you want to. There's a lot of striction, and so you have to like overcompensate for it when you adjust it and let it spring back, because it's 3D printed. It's two 3D printed parts, and they're fairly smooth, but not entirely so. So you have to be a little careful. Other interferometers, they have a tendency to be made out of metal, and you have adjustment screws that will move it one way or another, and you don't have to futz around with it. But I mean,
Yeah.
for a kit, this was pretty simple to go together, and despite its faults, it seems to work. So
Can I slip in a comment here since it's getting to be 9 o'clock?
yes.
Jürgen had a question for us, which I don't think we can answer. He wanted to ask on a smartphone. He's got a Android 11 TCL3X smartphone, $48 smartphone. It's got a default camera app function of 1/4 second in the pro mode, in manual mode, I guess. And he says he's wondering if he can download an app that would change the camera exposure time to more like 5 to 30 seconds. iPhones can do this, he says, and high-end Android phones have longer time defaults. So Jürgen is wondering if you know of any way of doing that. And
I have a friend that's got he's got a new iPhone, a new Android phone, and he gets pretty long exposures. I think there is an app that you can get.
Yeah, I saw a YouTube video on how to make these kind of adjustments to different phones. Androids were included, iPhones were included. It's really amazing what you can do with them if you know how to get at the buttons that change things.
Right.
So scout around on YouTube and find that for his phone. I'm sure you can do it.
yeah, and I saw somebody say about stacking, like doing a video of what you're looking at and stacking those frames somehow. So I guess,
Well, mail them to yourself and stack them on your computer. I
right,
don't know, the phone has the software to do that.
right. You have to download it to a computer to do that. Yeah. So, okay,
Anyways.
well, at least we asked his question for him. So that was, and so you didn't know who Derek Decker was, Jerry? This,
No,
he just, he was on Tim's previous telescope workshop list evidently. So he must have come to the workshop at some point or known Tim.
okay.
So
I
Tim's not
probably
here
met
to,
him, but I'm terrible with names. If I saw him,
I don't recognize the name at all.
Okay.
So, okay, so that's a couple things out of the way. All right,
So-
so we've reached 9 o'clock. Anything else?
No,
Nope.
Okay, so we're good for this week.
Good.
Yeah,
Give my
I'll try-
regards to everybody that I that are not here, and we'll see you.
Hope everybody's having a
later.
wonderful winter solstice. Longest
Okay.
night of the year.
And you have a wonderful umbrella to use tomorrow and for the next week.
Yeah, yeah.
We went shopping just to make sure that we didn't have to go on Highway 12 when it's raining.
Yeah.
Yeah.
We're supposed to get 2 inches over Wednesday, Thursday, Friday down here, maybe
Yeah.
more. Okay, folks,
Any
Thanks
feet
for
of
a good
snow in
meeting.
the Sears. Yep. See ya.
and I gotta stop sharing and click on in. Okay, good night.
Good night.